You've come to the right place if you're looking to buy a new computer or laptop for doing data science, machine learning, deep learning type work. Now you're going to want to watch the whole video because I'm going to save you a lot of money and buy you a specific build that is perfect for you depending on who you are. And if you have no idea what's going on, then I'm going to give you a really good suggestion on what you should do and how much that's going to cost approximately. So first thing I'm going to talk about is a little bit about how the computer works. And if you don't want to watch this piece, you want to get into, you already know how this works and you want me to talk about what I think is right for you, then skip the next little bit until I start talking about these things. But in the beginning, I'm going to explain, what RAM is, what a hard drive is, and that type of thing, because it's very important at a high level to understand what's going on. So there is RAM, which is basically the internal memory of your computer. It's going to be probably not 4 gigs anymore, although it might be. 8 gigs, 16 gigs, 12 is a somewhat common number, but less common than powers of 2, 32 or 64 gigs. There is a hard drive or solid state drive, which is where you actually store your files. So the RAM is just for, doing work. The file system is going to be stored on your hard drive or solid state drive, which is more like 128 gigs, 256 gigs, 512, maybe a terabyte, maybe 2 terabytes, and maybe you might have one of each of those things. The main difference between an SSD, solid state drive, and hard drive, HDD, is because a SSD is much faster essentially. That's really the only difference that's important. SSD is much better if you can get a hard drive. There is also a CPU, which is the thing that tells your computer what to do. So the faster is better, basically. And of course, more RAM is better, more hard drive space is better, more CPU frequency, or speed, basically, is very important. So it's going to be like a few gigahertz, basically, 2, 3, 4 gigahertz. The higher is better. And you may or may not have a dedicated GPU. If you don't have a dedicated GPU, then basically your CPU is in charge of doing GPU stuff. And the main point of that is to be in charge of graphics. So if you are playing games, then that is very important. But what a lot of people don't know is what they mean by doing graphics. They mean it's really good at doing linear algebra and kind of complex mathematics like that. And you could probably guess that for doing machine learning type work, this is very important. It's going to be doing a lot of that type of thing. So having a dedicated GPU is very useful. Maybe? It actually depends. And that's what we're going to talk about right now is, are you doing the work on your own computer, or what work are you doing on your computer, and what is actually being done on a different computer known as cloud? Okay, it is 2021 and it is totally possible for your computer to do next to nothing by just loading up a Chrome page, and you might think that your computer is doing all this work. It's like, wow, it's so fast. I'm using Chrome and it's like training this neural network. It probably is doing it on the cloud. If you are using Kaggle or anything like Google Cloud, Google Colab, any of these cloud tools, it is not being done on your computer. You are seeing results that are streamed to your computer where all of the work is actually being done on the cloud. So that very much so decreases the requirements of your computer. It means that you don't need a ton of RAM in your computer. More is better, but you might not need it. It means that your CPU might not need to be super fast. It means you might not even need a dedicated GPU, which, by the way, a good GPU is anywhere from a couple $100 to, upwards of several hundreds of dollars, maybe even 1,000 for the really top ones, which, maybe you do want depending on who you are. It doesn't hurt. And of course, whenever you're buying a data science and machine learning type computer, you're probably doing other stuff. Maybe you're playing games as well. Maybe not. That one's up to you. If you are playing games, get a dedicated GPU. The answer is that simple. And 16 gigs RAM. But for the data science and machine learning people, assuming that's all you want in a computer, well, so it depends whether you think you're doing it on the cloud or not. I can tell you, if you don't know right now whether you are doing it on the cloud or not, I would suggest that you do, because you can. It is maybe free, as in, say, Kaggle, if you're doing stuff on there, you have 30 gigs, or not 30 gigs, you have 30 hours free of a GPU who's going to make neural network training a lot faster. For those that don't know, like, seriously, a lot faster if you have just on a CPU compared to a dedicated GPU. If you're doing something like computer vision, training any sort of deep neural network, you are going to want the machine that's doing it to have a strong GPU. So you can do that on Kaggle, and you have 30 hours for free, and you could, I guess, make another account. Don't tell Kaggle I said that. I'm sure they know people do that, but you could get several accounts for free and kind of always have a GPU available. They also have what's called a TPU, which you will never ever see when you're buying your own computer because they are crazy expensive and make no sense to be in a computer most of the time. Basically, a TPU is called a tensor processing unit, and its job is to do neural network calculations very quickly. That's really it. It's to train neural networks and to perform neural network calculations or inference very, very quickly. That's it. So you have that available on Kaggle, or I think on Google Colab, kind of for free. You can also get an upgrade to get these things as their pro version. And it's awesome that they're for free, by the way. Thank Google so much for that. But you can also get a pro version where you pay just a little bit every month to get access to a GPU all the time, get access to more memory on the computer if you need that, more RAM, probably more hard space or hard drive space. By the way, it's confusing when I say hard drive space. Everybody says this. A hard drive is an actual thing that means a slow way of storing files, or physical thing that stores files. Hard drive also is kind of referred to as, it kind of also means an SSD, a solid state drive. That's just kind of historic. People say that it's always been a hard drive that stores the stuff on the computer. Anyways, aside from there, when I say hard drive, it may or may not mean, it just means the stuff that is storing the files in your computer. So basically, or was I? Basically, if you have a computer, regardless of what it is, it can train neural networks because you can do that on the cloud. But do you want to do that on the cloud? Well, it makes your stuff a little bit tricky sometimes. You do have to work with always manipulating the file system remotely, which is a very good skill to have, that you can do this in Linux or Python, manipulating the files. That's great. A lot of people may want to just do it on their own system, and the benefit of that is you always get a graphical user interface. You always get a GUI, meaning if you are doing some computer vision type task where you are moving pictures around, and say you got 100 different classes of vegetables that you're doing for a computer vision image task, well, that's going to be really tough to manage on the cloud. You probably can, but it's going to be a little tough to manage without being able to drag these things around and open them in File Explorer, whether you're using Mac or Windows. And I will have that operating system discussion, by the way, that I think is actually very important. So do I think you should do it on the cloud? Well, it's a very good skill to have. You may want the luxury of doing it by yourself. If you are on a low budget, I highly, highly recommend you do not get a dedicated GPU because they are very, very expensive, and just learn to do it on the cloud. That's totally fine. If you have a high budget and you're looking to, you might play games as well, then it's okay to get a good dedicated GPU, something by Nvidia. I would just go with their normal, very common stuff. Right now, as of writing, 1660 Ti, 2060, 2070, 3060, 3070, something like that. Some of those are very expensive, but they are very good. Some of the AMD stuff, I'm not as familiar with the names of the AMDs because it's a little less popular, but they are quite good. For this type of thing, I highly recommend you just kind of compare for a long time of different GPUs, whatever you want to use. Okay, so regardless, if you want to do training on your own computer, you do need a GPU. So look into one of those common ones I just said and just benchmark different ones against each other to see how well they're doing, how well they are in the total of what's totally best, and see how fast they are. If they do what you want them to do, you can benchmark and read those things. But I'm telling you right now, just get one of the common ones. That's going to help a lot. Okay, so we talked about GPUs, RAM. How much RAM do you need? Well, if you are doing it in your own computer, so if you were doing all the training on your own computer, you are going to want 16. I can tell you that right now. 16 or even 32 would actually help if you're doing computer vision type training tasks on your computer. Any deep learning, really, it's going to help a lot if you get up to 32. 8 will do it. It will do it, but it's going to be a lot slower unless you have more RAM on your computer. So I highly recommend that. If you are not doing it, if you are doing it on the cloud, so if you're not doing the training on your own machine, you plan on doing that on Kaggle, then what I'd probably do is get 16 anyway, because that's where I think it's headed. But again, if you're on a tight budget, then you might want to go to 8 because it will run that task fine of training neural networks on the cloud, at least as of writing. But 8, there's so much bloatware, and bloatware just means like kind of useless stuff running in the background. There's so much stuff running in the background now that 8 gigs is just not enough. Like, even on a phone, they are getting like 6 minimum now for even like a mid-range phone. They're getting up to like 8 and 12. And that's because stuff is so much stuff is running in the background that you actually kind of need that extra RAM. So I highly recommend to honestly never in your life buy a computer that has less than 12 gigs of RAM. 12 is probably good. 16 just makes more sense. If you can afford it, I would never buy a computer nowadays that has less than 16 gigs of RAM. I think it's dead. A lot of people now think it's dead. There's no place for it in at least a gaming computer. There is sort of a place for it if you were doing it all in the cloud and you were trying to save money. But I think it's a really good upgrade. In terms of any like minor upgrades, it's not minor. Like it's one step up pretty much, but it's something you will want for sure. All right. So we talked about RAM. I would highly recommend 16 or above. 32 wouldn't hurt if you're doing it on your own computer. Otherwise, it's kind of overkill. We talked about hard drive space. So how much hard drive space do you really need? Well, and again, I mean SSD included. Get an SSD for sure instead of a hard drive. I don't care what anybody says. Hard drives are, I think it's kind of dead technology in 2021. They're a little more expensive. If you're really on a budget, I would not recommend this is where you cut it down to getting a hard drive. They are a lot slower at every single thing. You are always loading stuff from that hard drive into the RAM in your computer. It's just always doing that. And you're going to want an SSD that'll do that way faster. And you'll notice it significantly when you have to reboot your computer, which I do all the time. I reboot it several times a day. It just does it right away rather than takes a very long time. And doing any neural network training, SSD is so much better. So I highly recommend. In terms of actual physical space on it, well, I would shoot for a terabyte if you can. Probably half a terabyte is fine for most things. Again, if you're going to be storing, say, images on your computer for doing training, it's probably not that big and you can move it to a drive afterwards. You can probably fit it on half a terabyte, as in like 512 gigs. In terms of any lower than that, 256 gigs, it's getting kind of down there and you're going to run out of space just doing general stuff pretty quickly, especially if you have anything else running in your computer. Like if you have any games, then you need to push it up for sure. So I'd probably shoot for a terabyte. 512 will probably do any task. And this one, honestly, it's probably about the same for each person, whether you're doing stuff on the cloud or if you're doing it just on your own machine. Bigger is better, but it's probably fine if you're half a terabyte or above. I'd probably shoot for a terabyte nowadays. So for the other components, we talked about RAM. Bigger is better, 16. Hard drive, terabyte or so. Get an SSD, solid state drive. You are going to want so CPU is really the last one, I guess. So I talked about GPU, RAM, hard drive. CPU, I would just kind of get the one that is popular. If you're getting a laptop, there's a couple really popular ones right now. For example, 10750H, probably 11 is going to be like the same name or something similar. You will often just kind of start to see laptops in the same price range with the right processor. We absolutely could have the discussion of i3, i5, i7 versus the AMD stuff. I'm an Intel guy, so I would go with anything in the i series over anything in the AMD series. A lot of people will complain about that and say that I should be looking at the AMDs. The reason for this is just because I kind of trust Intel to do the right thing, and I've had a bit of problems with AMD stuff in the past, but so many people are going to say, I've never had a problem with it, and it's probably true. I bet you they're really good, and they are competing for price, so absolutely look into benchmarks and what YouTube videos, other people's videos, are going to say about specific AMD and Intel processors. But what I can tell you for sure is that if you get the standard i7, whatever that is, at the time, it's 10750H basically. If you get that, it's going to do everything properly, and you just won't really see a slowdown if you have enough RAM, 8 or 16 gigs, probably 16. You won't see slowdowns in pretty much everything that you do. It's going to be great. So I highly, highly recommend you get an i7. If you do look into the i5s, which are slower, so it goes i3 is basically dead, so I wouldn't get an i3. i5 is basically mid-range, and i7 is really good actually. And if you can get an i9, then absolutely go for it. But I doubt you're watching this video if you can afford an i9. So i5 versus i7. i5 it's tricky because most of the time you're okay, but then sometimes you're going to be doing some tasks that are just, it's going to be a little bit slow, and especially if you're doing any training on your own computer, I would definitely get an i7 because on an i5 it's going to handle it, but it'll be a little bit slow sometimes. It's the tricky thing about the processor is that if it sucks, everything else sucks. And that's true about RAM as well. If you have little RAM, everything else sucks too. So that's why I'm saying just go for 16 so that you never have that problem. Your CPU, might be a place to get a budget, but I'm on the side of just try for i7 if you can. And if you really need to get a budget, then get an i5. That's totally fine for most tasks. But probably you would do the training on a different computer if you are going to get an i5. And the AMD stuff, look it up. I'm not really an expert there. I trust Intel a lot more, basically. So we talked about CPU, RAM, hard drive space, and a GPU. Those are the main components you're going to look at when you start to buy a computer. And when you look at the title of what a computer is, those are the main things that are going to come up. It's going to ask you, it's going to say 8 or 16 gigs RAM, most likely. It's going to say, if it advertises a GPU, that means it has a good GPU, and you're probably going to want that. Or you're probably going to enjoy the GPU that's in there. If it's not advertising one, it probably doesn't have one, or it's one that's not very good, or it's just a bad advertisement. But usually they would try to flaunt the good things like a GPU. And it's going to say how big the hard drive space is, or if it's an SSD, most likely. All right. Those are the main components. The other stuff is you do need a good resolution computer. It is important. I would shoot for 1920 by 1080 resolution at a minimum. If you don't know what this is, it's basically how many pixels are stuffed into a square rectangle, and that rectangle is your screen. And so how many pixels are in there, the more is going to make it look better. 1920 by 1080 pixels. It's going to be looking pretty good, and it depends how far your eyes are from the screen. So if I was looking at my computer really closely, I would actually see that the resolution is really poor. But that doesn't matter because I'm looking at it from, a pretty normal distance, and so it looks clear at 1920 by 1080. If you can get a 4K screen, which I believe is just double that resolution, it's a lot better. Or is it 4K because it's 4 times? I don't know. I forget. Anyways, you want to get a good resolution computer. Anything above 1920 by 1080 is just fine. I would be happy with that. And in terms of the other aspects of the screen, contrast, brightness, I'm not going to get into that, but for neural network training, it's not really that important. It's not going to hurt your eyes to have, bad colors in a screen, but it's more so if you're doing like video editing or something like that. And I mean, like I don't just mean if you're doing a video edit. I mean, if you're really, really doing like it really matters what the photo looks like with the different colors, then maybe look into that, but it's not a big deal. So screen, good resolution, should be fine. The final thing is that you need to look at reviews about all of the other stuff, because you could you could just listen to what I said, which, by the way, my recommendation is for people that are going to use it on the cloud. It's 8 or 16 gigs RAM, a half a terabyte or terabyte drive, and no GPU with a fast, probably i7, maybe i5 CPU. And for those that are training on their own computer, it's going to be an i7 with a pretty good GPU. So it's probably something Nvidia, their normal series, 1660 Ti, 2060, 2070, 3060, 3070, something like that. And 16 gigs RAM for sure. So those are my 2 builds for each person. The other stuff, it's extremely important to just watch a review of every single thing you look up. And I don't even just mean that there's many different models in a computer. So I could be buying what's a common laptop? Well, I bought the Acer Predator Helios 300, for example. And there's like 100 of these things because there's slightly different RAM combinations, 8 or 16 or 32. There is different GPUs, absolutely. So I bought the one with the RTX 3060, which is a great GPU for doing everything. And so there's so many different models in a computer, just tiny different things, but you need to watch a video of the particular model, somebody else using this thing, because there might be a huge problem with it. And if you want to have the conversation about brand loyalty, it is now, because there is, from what I'm aware of anyway, there's not a single computer brand that has not built a piece of crap before. What I mean by that is there's always a pretty big problem with some of them. That doesn't mean you have to return it. Doesn't mean there's an instant refund with this product. But even something like Razer, which people love, and in my opinion, a little bit overpriced, but people love them, and I bet you they're awesome. I've never had one. Some of them have heating problems. Some of their GPUs really toast up the computer, and it's gonna make it slower. So you cannot just look at the specs and say, oh, this thing has a better GPU than that one, therefore it must be better. The answer is probably, but do not trust that. You have to watch a review of every single computer, every combination, and if you can't find one, I would be extremely hesitant of buying something that's nobody else has used before. There's so many different channels of people reviewing computers, and you're gonna want to just watch whatever they put out. Just search exactly the model that you were thinking about buying, and then look a video up for it. So my guide is, here's the specs that I think I want. I said those, and I'm going to put them down below for each person. But it really depends what the actual model of the computer is. You have to look up in the computer in a way. Sorry, I'm getting off topic. You need to look, when you're buying a computer, you need to look up, okay, this is the specs, and I know how I think this thing is. So you're going to look at like hundreds of laptops, hopefully, and it's going to take a while, seriously. You're going to look at 100 different laptops, and you're going to discard so many of them immediately because you can look at the price and be like, okay, no, this one's GPU is a lot better than that, so I don't care about that for this price. This one has 8 gigs RAM. I don't think I want that for me. This one has a hard drive and not an SSD. I don't want that. Anything like that, all of those combinations, you can do that pretty quickly by knowing the things I just said. i7 is a lot better than i5. 16 gigs is a lot better than 8 gigs of RAM. SSD is a lot better. Any dedicated GPU is a lot better than not having one, and there's different levels of how good one is. You can do these calculations in your head very quickly, say, nope, this one's better right now. Nope, this is better. Always have like a couple winning ones in your mind, and you think are really good for the price. And then before you buy any of them, make sure you watch a YouTube video for all of them, a couple of them all the way through, where people are testing the thermals, so how hot this thing runs, and whether the screen looks like complete crap or not. Maybe it does, it probably doesn't, but you gotta look at those things. Stuff like the keyboard, you think it doesn't matter, like it's like, oh, it's just a keyboard. Like, no, some keyboards suck. Like, some of them actually just don't work. Like, I've had computers before that have amazing specs in them, and you go to type stuff and it just doesn't type. You need that. So the only way you would know that is by watching or reading a review, so that you could also read them as well. Be mindful that some of the stuff you watch, people are promoted to, talk about them being good. Supposedly they're not allowed to, say only positive things about these things, but they are going to say mostly the positive things about them, so do be mindful of that. Just watch a video or review of every single thing that you have. Have a couple winning ones in your mind where it's like, okay, this is the best one. No, this is the best one. You have the best one. Watch a video of it. If that is the right one, then that's the right one. And I've said a million times what my recommendation is. I will say, regardless of the two groups of people, whether I think you're going to do it on the cloud or mostly on your own computer, the bare minimum is i5 or something AMD equivalent. It is 8 gigs of RAM. I highly recommend 16, and I'd also recommend an i7 over it. And you don't necessarily need a GPU. Okay? If you're training on your own computer, you do. Otherwise, you don't. So, if you like this video, comment down below and ask me any questions about what you have about laptops and computers. I can absolutely help with that. Recommendations, I can absolutely supply some of those. And if you like the video, please subscribe to the channel and give the video a like. So thanks so much for watching. I will see you next time. Bye-bye.